Welcome dear students and parents. I am SRIKANTH SUNIL, senior most faculty at the VISHRA IIT JEE Academy, which is located at Balapur X Roads, near to Kalbi Nagar. Today we are going to discuss the evening session paper on 23rd of January. 23rd of January evening session paper. We are going to discuss chemistry now. So let's start our discussion. Students, these questions are very important models. So I request all of you to be very attentive while teaching these problems, and you try to practice similar type of models which will be very useful for the students who are going to write tomorrow and day after tomorrow, those who are writing, and on 28th and 29th also. So welcome students, let's start the paper. So this is JEE Mains 23rd January evening session. So let's see the first question. Question number 1. In this question number 1, the melting points are given. This is group 14, which is oxygen group. So the melting points are given. So in fact, group 14 means carbon group. Carbon group melting points are given. The melting points are like this. Carbon will have more melting point. Of course, we are taking carbon in the form of diamond or graphite, and then germanium 10. Then we'll have lead, and last we have tin. Tin will have less melting point. So this is the option. Different orders are given. You have to identify the correct order, and this is the order which we can write. So then let us go to the second question. It is about alpha helix structure and beta helix structure. Alpha and beta helix structure and alpha and beta pleated structure. What is this structure? This is the structure of proteins. Fibrous proteins or globular proteins. So let us see what is the question. Alpha helix protein and beta pleated sheets protein belong to which one of the following type of protein? Structure. They are asking about structure. See, in protein, there are 4 types of structural explanations. Primary structure, secondary structure, tertiary and quaternary. This alpha helix or beta pleated will come in secondary structure. Remember that these two are coming in secondary structure of proteins. So they are asking alpha, primary, secondary. So you have to write secondary. So then let us see the next question. What will be the effect of pH of water when it is heated? When it is heated, what happens to the pH of the water? pH of the water decreases. pH decreases. The question is why pH will be decreased? Generally, all of you know that Kw is ionic product of water, concentration of H plus into concentration of OH minus. This one is 10 to the power of minus 14 at 25 degrees Celsius at room temperature only, and at 50 degrees Celsius or even 75 degrees Celsius, this may increase and become 10 to the power of minus 13 or 10 to the power of minus 12. So if it is 10 to the power of minus 12, then H plus concentration is also increasing, pH is decreasing. That's why pH is inversely proportional to concentration. pH is inversely proportional to concentration of H plus or activity of H plus, we can say. Like that, we can explain the third question also, students. I think all of you understood. When a solution is heated, which contains water, the Kw value will increase. Increase means 10 to the power of minus 14 becomes 10 to the power of minus 13, which is increase. 10 to the power of minus 12, which is also increase. So that increase we can calculate and we can calculate the pH. pH will give less value than before. So like that we can explain. Let's go to the next question. 3 are over. Fourth question. There are some alloys given, and we can remember the alloys and we have to tell or match the composition. So let us see the alloys. First one, A is bronze. B. B is stainless steel. Stainless steel is all our plates and everything that we are using. Stainless steel. Third one is UK gold coin. Of course, most of it will be gold and some other things will be also mixed in that, and brass. Brass is the last one, which is D. And here they have given iron, chromium, and nickel, like this they have given, and copper and tin they have given, and copper and zinc they have given. And remember that gold, silver, copper, zinc, most of things are given here. So of course, in this there is no gold, no gold, no gold. Here gold is there. So I'll put UK gold coin for gold. First one is over. Next, bronze contains Z, so it should not contain zinc. Bronze contains Z, so it should not contain zinc. It will have copper and tin. Of course, brass will have this Z, and this one is the combination iron, chromium, nickel is galvanization, and we are able to make it. So this is the match the following. For this question, you can easily answer that. So let's see the next question. The next question is about the graphs, and which one is a zero order reaction we have to tell. See this one is the first. This one is the second one. Yes, students, we'll start the fifth question. Let's move to the fifth question. Fifth question is from chemical kinetics, and this one is having some graphs. So let us see the fifth one. You have to identify which one is a zero order reaction. See here, there is a graph between rate and concentration. It is not dependent on the concentration. Rate is not dependent. Then there is a graph where rate is there, concentration is there, and this is one more graph. There is a rate and concentration here, and the graph is coming down, negative slope, and rate and graph are between concentration. It's a parabolic, it's a hyperbolic type of graph. So in this, you can say that rate which is not dependent on concentration is a zero order reaction. So this one is zero order reaction. This one is zero order reaction. This one is zero order reaction. So that is question number 5. So let us go to the question number 6. In question number 6, delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T. This one is Gibbs free energy. Gibbs free energy. How we can understand this? Which of the following reaction is incorrect for spontaneous reaction at a given temperature? If you want a spontaneous reaction, see here, spontaneous reaction. If you want, delta G should be negative. Delta G should be what? Negative. So spontaneous reaction. So see the option, this one, delta H is greater than 0. So it is positive. And delta S is less than 0, which is negative. So if this part is positive and this part is negative, obviously delta G will be positive, and it is a non-spontaneous, not spontaneous. So we can say that delta H greater than 0, delta S less than 0, this one will be a non-spontaneous reaction. Means delta J will not be negative. It will be always positive. So reaction will not happen by itself. That is the question number 6. Let us go to question number 7. This one is assertion reasoning type of. So related to this, statement number 1. Statement number 2. Statement number 1 and statement number 4. For a particular shell, maximum number of orbitals is n square. For a particular number of shell, maximum number of orbitals is m square. Okay. Then, for a subshell, possible orientations are between minus L, 0 and so on up to plus L. This is also correct. This is also correct. For a subshell, L will be given. For the main shell, N will be given. So, both are correct. Both are correct statements. Like that, we can explain the statements. So, let's move to the 8th question. 8th question is an organic based question. So, let us see what is this. This one is 7th one. I am teaching the 8th one. 8th one is like this. Chlorobenzene is taken. To this chlorobenzene, first NaOH is added. NaOH is at very high temperature and pressure. High temperature and pressure. And the second one in the base of an acid. In an acid we are giving. So then A will come, and from that A, K2Cr2, some strong oxidizing agent. This one will make it H2SO4. This one will make it B. So let us see. When Cl and strong acid is there, you can get this compound. What is this compound? OH is coming. First, this compound is obtained. Dow's process. Then this one will convert into this because H plus is there. It is in the textbook, NCERT based question. Now this one will be oxidized and this one will give high. This is quinone. So the option is phenol and quinone. These two will be the A is this one, B is this one. So like that we can explain the so Dow's process can be explained like this. Then let's move to the 9th question. Question number 9. So what is in the question number 9? Complex compounds. D4 configuration. Which one will have D4 configuration? D4 configuration means this one is the configuration. 1, 2, 3, 4. One should be empty. That is a D4 configuration. So let us see which one will have D4 configuration. First one is given as FeCN taken 6 times with a charge of 3 minus. Second option is Mn F6 with a charge of 3 minus again. Both are octahedral complexes. Third one is CO Cn taken 6 times 3 minus, and fourth one CO Cl4 2 minus. So this one is tetrahedral. These 4 tetrahedral are square planar. We have to understand that. Here ligands are 6, so it can be octahedral in shape. So let's see what will be the answer. See, this one will be the answer. Check this. Mn plus 6 into minus 1 is equal to minus 3. So Mn is equal to plus 3. Mn is equal to plus 3. Mn is equal to plus 3 means it will have 3D 4 4s0 configuration. Yes, 3D4 4s0 configuration. Like that we can explain the electronic configuration. So this is the second one will be the answer with the D4. Like that we can move on. Let's go to the 10th question. Question number 10. Total number of isomers possible, aldehydes and ketones only they are asking. C4H8O. 10th one is C4H8O. in this, how many isomers are possible? These isomers should be CHO group or CO group. Aldehydes and ketones. How many are possible? So, 3 are possible. 3 are possible. What are those 3? See here, this one is the first one, and the second one, this one is the second one. This one is the third. There is no other possibility because only 4 carbons are there, so no other ketone. Only 1 ketone and 2 varieties of aldehydes. Observe this. This one is a linear, this one is branch, this one is ketone. Like that we can explain the 10th question. So let us go to the 11th question. Question number 11. Consider the following reaction. See the reaction X2Y, which is actually a solid, which is in equilibrium with X2 gas plus you will have half Y2 gas. This one is the reaction. If alpha is the degree of dissociation, calculate Kp in terms of P. How to calculate Kp? Kp, how to calculate the formula? Just we have to write the formula for this. So see how I am calculating. Observe this carefully. Okay, here let us say P dash and P dash divided by 2 is there. It's half, it is 1 mole. So P dash and P dash 2 is there. So P total is equal to 3P dash by 2, which is equal to, this one is solid. So there is no pressure because of solid. So 3P dash will be there, and this one can be written as implies P dash is equal to 3P total, 2P total by 3. 2P total by 3. So when we calculate that, obviously we are getting Kp value is equal to, we are getting 2P to the power of 3 by 2 divided by 3 to the power of 3 by 2. This one is the option. Carefully we have to do, students. It is on the pressure. Pressure, mostly they are giving on pressure. So this is how we can do the pressure. Applying that. Then question number 12. Question number 12. So they gave a graph like this. This graph is having V0 here, 2V0 here, and 3V0 here. This one is having P0 and this one is having 2P0. Two P0 and draw the graph like this. This is an arrow which is going like this. This one is the arrow which is coming in this direction. So here they have divided this into 3 parts like this. And here it is A, and here you have B, and here you have C, D, and E. This is how you can draw the diagram. So now they are asking that ideal gas undergoes from process. Find work done. Work done means A to B, B to C, C to D, D to E. Work done. Okay, so work done is always area under the curve. Work done is always area under the curve. So this one is equal to 2P0. Here P0 is that 2P0 into change in volume 3V0 minus V0 minus P0 multiplied by 3V0 minus 2V0. This one finally gives you 3 P naught V naught. This one is the actual net work done. So it is the area under the curve. What curve you are drawing? Under that area you have to find. So let's go to the next one, 13th question. Question number 13. In question number 13, when a non-volatile solute is added to a volatile solvent, the vapor pressure of solvent decreases by 10 m. Means P naught minus Ps is equal to 10 mm of Hg. Mole fraction of solute in the solution is, mole fraction of solute is equal to 0.2, mole fraction of solvent will be always equal to 0.8 because both should be equal to 1. If another non-volatile solute B is further added to the same solution and vapor pressure of solution decreases by, this is for A. If I take for B, P naught minus Ps is equal to 20 mm of mercury, and this one is B, and here calculate mole fraction of the second solute. Mole fraction of solute we have to find. Solute in B solution. This is how we have to do the problem carefully. So let me explain this, how we are doing. X of A is equal to 0.2. So delta P is equal to 10 mm of mercury. So we are applying that. P naught minus Ps by P naught is equal to X of A, which is equal to 0.2. So P naught is equal to 50 mm of Hg. After getting 50 mm for solute, we have to calculate XB. XB is equal to number of moles of B by 0.2 plus 0.8 plus NB, which is equal to NB by 1 plus NB. So delta P is sum of all this. 10 plus 20 is equal to 30 mm of mercury. So actually they are asking the mole fraction. So mole fraction also to be covered. Mole fraction we are getting XB. XB is equal to 1 by 1 plus 1, which is equal to 0.5 because it is 1 by 2. 0.5 it is. 0.5. So that's how we will do the problem there. Very easy and simple. But calculation we have to do properly. This is question number 13 based on relative lowering in vapor pressure. Question number 14. Question number 14. So in question number 14, E naught of silver with silver is given as 0.8. E naught of Zn plus 2 with Zn, it is given as minus 0.76 volt. This one is plus volt. E naught of copper this one is given as plus 0.34, and E naught of magnesium, which is a more powerful reducing agent than zinc, it will have minus 2.36 volt. Magnesium is very powerful. So then which of the following will have the most negative value of delta G? Delta G naught is equal to negative. Which one will have most? So the most negative value will be between this value minus big value and in positive big value. So these two you connect. Magnesium is a good reducing agent. Magnesium bar Mg plus 2. Salt bridge. Silver plus bar silver. This one will give you the maximum spontaneous reaction. The EMF of the cell will be high positive, so delta G will be negative. All of you know that delta G naught is equal to minus NF E naught of the cell. Where E naught of the cell is maximum, then delta G naught will be maximum. That is the concept. Delta G naught will be very highly negative when E of the cell is highly positive. So observe this. I think all of you understood. This is minus in minus values. This one is the big value. Plus value. This one is the big value. Both of them you have to combine in such a that what minus will come on the left hand side, plus will come on the right hand side. Simple. So let's move to the next one. This is question number 15. And this question is on organic chemistry. Organic chemistry, very easy this one. Take this compound. Big structures are there. Don't get scared by seeing these structures. This one, when you do the ozonolysis, this one will break here. This one will break here. On ozonolysis. Ozonolysis. Which compound is about to come? Here you have COOH. C double bond O, and here COOH will come, and here also you have COOH. So that's the first compound. Second compound is also there. Observe this, is like benzene but not benzene, like azulene. So here this double bond will break, this double bond will break. Ozonolysis. Ozonolysis. Double bond breaks. What happens? It becomes oxidative ozonolysis. It becomes oxygen and COOH is obtained. This one will be reacting with this, and here double bond O, and here that's the compound. So like that, many compounds are given which are almost similar to this. Here there is one more compound like this. This one on ozonolysis. This gives a COOH compound, and this one gives the C double bond O, and here COOH, and here. Yeah, these are the ozonolysis compound. We have to identify the ozonolysis compound and give the proper connection to that. Match the following. Okay, this one is correct. All these are correct reactions I am writing. So arrange the following compounds in the decreasing order of the rate of hydrolysis. So next one is question number 16. They are asking the rate of hydrolysis. See the compounds. There is a compound like this. Here Br and here Br is there. Here Br and here Br is there. This is one more compound where we will have the benzene with Br, bromobenzene. This one is a compound with and of course you will have this compound which is a normal compound. So these are the four. So what is the question? Give the decreasing rate of hydrolysis. Remember, the answer is most stable carbocation gives fast reaction. Most stable carbocation gives fast reaction. Let us say this one is A, this one is B, this one is C, and this one is D. A, B, C, D. In that, B, when Br is taken, this one is a least stable carbocation. Phenyl carbocation is least stable. Then let us see the order. So, this one is more stable than this one is more stable than this compound. One Br is broken here. So here Br is still there, plus sign is there. Here two Brs are there, Br1 and another Br. So then this one. This is the order. So what is the order? C is more fast, then comes D, then comes A, and last will have B. This one is the order. E's are the decreasing order. This one is more stronger. This one is least. So that one is the order that we are explaining. So let's go to the 17th question. Very easy question. Combustion of hydrocarbon. Combustion of hydrocarbon. All of you know what is the combustion of hydrocarbon reaction? CXHY plus X plus Y by 4 O2 gives you XCO2 plus Y by 2 H2O. This one is combustion of a hydrocarbon, general hydrocarbon combustion. So what they are giving? What data they have given? 0.01 mole of hydrocarbon. This 17th question is an organic chemistry question based on the combustion of hydrocarbon. So this is the general equation for combustion of hydrocarbon. And whatever data is given, I am writing here 0.1 moles of organic compound hydrocarbon gives 1.76 grams of carbon dioxide, and also it gives 0.9 grams of water. Okay, they are giving on complete combustion. Find out chemical formula of the compound. So X, I want to calculate. What is X? This is X. X moles of CO2. This one is equal to 0.04 divided by 0.01, which is equal to 4. X will give us 4. Remember that. In the same way, Y by 2 is equal to 5. Implies Y is equal to 10 or not? Yes, 10. So this compound is C4H10. This one on combustion it gives like this, and these parameters will be accepting or obeying the equation. Next, there is a question, 21st question. Let us see. There are 1 or 2 questions which are missing because our students are not able to memorize that properly, so we are not able to produce that 2 or 3 questions. Some other questions are there. 21 question I want to explain. So let's move to the 21 question. I think all of you understood this. Very good. Take this compound, again organic chemistry, and talking about amines. This compound, they are doing diazotization. NaNO2 plus HCl. They are doing that in the presence of 0 to 5 degrees Celsius. This is diazotization. So diazotation, what is it going to give? This one is going to give a compound that is A. I am writing the A here itself. What is that A? Wherever amine group is there, that one will become diazo compound. And other side, it is like that. It will not change. Now, to this, they are adding phenol. To this, they are adding phenol. If they are adding phenol, what happens at a pH of 8? This one will give a coupling reaction. What it will give? It will give a coupling reaction. So, we are doing coupling. This is known as coupling reaction. It is in our NCERT book. So, what happens? What happens to this? So, let's see. There is a benzene ring. This one is the benzene ring. There is a OCH2, CH3 here. And here there is nitrogen with double bond nitrogen, and there is a benzene ring in the para position which is there. This compound is formed. But they did not stop here. This one is actually an azodine. But they did not stop here. What we are going to do? They are going to react with the CH3, CH2, Br. So this one goes and reacts here where oxygen is there. So we'll get the compound like this, benzene ring with N double bond, N single bond, again benzene ring here, and here you have OCH2, CH3, and here also OCH2, CH3. So in this sp3 carbons, they are asking. After doing this, we have to find out how many sp3 carbons are there. This one is sp3, this one is sp3, this one is sp3, this one is sp3. All the ring carbons are sp2. So sp3 carbons are 4. This one is a integer quotient. 4 is our integer answer. Like that we have to answer. See how I turn that A compound into B compound, B compound. After this, it gives the final answer. In that, only sp3 carbons we have to identify, not the other carbons. Let's move to the 22nd question. This one is the last question that we have identified. So all of you see here, 22nd question. The compound X consumes 2 moles of H2 when X heated with KMnO4 with H+. Okay, so gives number of sigma bonds in X is, see here, C double bond CH3 attached to CH3. This one is acetone, and this one is acetic acid. And we have this CH3, C double bond O, CH2, CH3, COOH. In fact, CH2 only here, CH2, COH. Okay, so number of sigma bonds you have to find. Remember, X compound is like this, CH2, in fact CH3, carbon CH3, double bond C with CH3, single bond CH2 bonded with CH2, CH double bond CH, single bond CH3. This one, when KMnO4 is there, then this one will break like this. This is the compound X. This compound X is giving these compounds when KMnO4 O4 in H plus is given. All these three it's given. So, how many sigma bonds are there in this? We have to find out 3 plus 1, here 3 plus 1, 4 plus 4, 8 plus 1, 9, 10, 11, 11 plus another 2, and here also 2, and you have to count all these. You are getting number of sigma bonds is equal to, number of sigma bonds equal to 27. This is the integer. These are the questions, dear students, that we are able to grab them and we are able to present before you. All of you carefully understand this concept, study the overall concepts which are related to that, and so that you can get more marks in the coming sessions. And we expect that most of the similar questions will be there in the question banks. So these question banks will be repeating. There are some sessions where similar type of questions are also repeated. So better you see the PYQs of the 2024 papers and you see the upcoming papers from our VISHRA IIT JEE Academy. Remember students, my name is SRIKANTH SUNIL, teaching you the chemistry paper of 23rd morning session and evening session. We are from VISHRA IIT Academy, Balapur Exports. Thank you.